Erik Johnston with Allan Ltd. I'm a project director and senior mechanical engineer.
Okay. In your presentation today at ITS Convention, you talked vividly about the naval architecture of the Svitzer Balder project and also the challenges and solutions.
Yeah.
Could you give us some information, please, on some of the key design aspects of the vessel?
So the biggest challenge was integrating the two energy systems on board, battery electric and the methanol fuel systems. The two systems and their auxiliary supports required space in the vessel, and often those two systems wouldn't be in the same areas of the vessel. So we really had to work as designers with Svitzer and Uzmar in close collaboration in finding the optimal solution for integrating all those solutions into one.
How did you go about the general arrangement for this?
There was several iterations. The biggest challenge was finding the optimal solution of placing methanol fuel tanks and the batteries. The batteries are quite heavy and something that is always on board, where the fuel tanks are variable, though, depending on how much it's being consumed. And so we're trying to get the batteries closer to midships so that they're not causing great trim on the vessel.
So one final question. How have you taken the lessons learned from this project into future tug design?
Yeah, so one of the biggest lessons learned was the underwater venting system. So when we began the design of our methanol tugs, we started with following what we had done on LNG tugs, which was to have the tank venting go off the vent mast. But we quickly learned through collaboration with the shipyard that in particular the radars could not be purchased as ATEX rated, and so they couldn't be within any hazardous areas. And the methanol tank venting creates a large hazardous area, and it was impossible to coordinate everything and get the radars and other communication equipment outside of that hazardous zone. So we looked at underwater venting, and we had to do our own research on that. So we collaborated with a company in Canada that did some physical model testing of the venting system, and then validated that further with our own internal CFD review. And it was determined that the system works extremely well, and almost all the methanol vapor that comes out in the underwater venting system is absorbed in the water column. So it's very successful.